Hello, welcome back. So this part is in continuation to the previous part. So we were solving the example one, and we have solved step 5 in the previous part. So now I'm continuing from there. So in this we are going to solve step 6. So in the step 6 we are supposed to find out the compressive strength of lacing bar. Now compressive strength of lacing bar, we have seen that formula earlier. So compressive strength of lacing bar depends on FCD. So FCD depends on the lambda value and Fy value. So we know that our built up column and whole its section belongs to class C. I have discussed this earlier also. So we are going to find out FCD value from table 9C. So slenderness ratio of the lacing bar is 116, and again the yield strength of the lacing bar is 250. So by using table 9C, again we will look this table to find out the value of FCD, and once we find out the value of FCD we will find out the strength of lacing bar. So strength of lacing bar is AE into FCD. So putting all the value, so AE is the effective area of the lacing bar. So again I'm showing you the lacing bar. So lacing bar is this one. So this one is B and this one is T. So cross sectional area is B into T. So here it is written as T into B multiplied by the FCD, and now getting the value of compressive strength as 52.84 kilonewton. So this is the strength of lacing bar, which means this lacing bar can take load up to can take compressive load up to this one. Now after this we are going to find out how much force this lacing bar is going to experience. So because of the external load, how much force lacing bar is going to experience, and that force should be less than this one. If it is not less than this one, then we have to revise the design. So now in the step 7 we are going to find out the force, and this force is dependent on V value, which is 2.5% of the P value. Now P value is already given in the question, which is 1000. P value is actually the 1000 kilonewton, which is a factored load in the built up column, which is required to be supported. So now we will find out maximum shear, which is 2.5% of the P value. So as I said, P value is 1000 kilonewton. So maximum shear force is 25 kilonewton or 25 newton, 25,000 newton. So this is as per clause. So this is mentioned here. So now we are going to find out the force, and force in the single lacing system can be given by this formula. I have explained this formula earlier, so you can refer to that if it is not clear to you. So by putting all the value in the single lacing system, n value is 2, so V by 2 sine theta, and putting all the values we can find out the force in the lacing bar as 17,675, which is 17.675 Newton. So you can see lacing bar will experience this much force, while the strength of lacing bar is more than 50, which means it is safe. So we can say that yes, this is the transverse shear force, which is divided on both the panel. This was actually the background point. So in this case, you can see compressive strength of the lacing bar is 52.84, and it is more than the required force, which means the lacing bar will experience this much force, while the capacity of the lacing bar is 52.84, which we have calculated in the previous step. So therefore we say that the lacing bars are okay, they are safe, they can carry the required load. Now we are going to find out the compressive, we have already find out the compressive strength. Now we are going to find out the tensile strength of the lacing bar, because sometimes because of the reversal of the stress, lacing bars may experience the tension force also. So I have already discussed the chapter, I mean the lecture design of tension member. So based on the design of tension member, we are going to find out the strength of lacing bar. And in case of tension member, we generally find out the strength of bar in two aspects. One will be in rupture and the other one will be in yielding or gross yielding. So this is the formula that we use to find out the rupture strength. So you can see TDB, sorry, TDN. So this is the formula for the TDN, which is 0.9 into AN into T, sorry, into FU. So the same formula we are going to use here. So AN, there was the net effective area, and here the net effective area will be B minus DH. So there you can see if this is the lacing bar and on the ends it will be connected say by the bolts. So in that case the net effective area will be across this section. So in this case it will be say B value, and the dia hole will be say I'm writing it as DH. Okay, and the thickness of the lacing bar will be T value. So this is how we find out the AN, which is B minus DH into T. So this is the AN value. So that is the same formula for the tensile strength to calculate the tensile strength of the same lacing bar. So the same formula for this. So now putting all the values, we can find out the rupture strength of the lacing bar as 113.36 kilonewton. So the tensile rupture strength of the lacing bar is 113, but we also need to find out the gross strength, which is the TDB. So you can see TDB is equals to AG into Fy upon gamma m naught. So this is the same formula. AG is the gross cross-sectional area of the bar, and Fy is the yield strength. So here AG will be B into T. So putting the value again, and here the gross strength of the lacing bar will be 136.363. So the least value will be taken as the tensile strength of bar. So the tensile strength of bar will be 113.36 kilonewton. So again you can see the bar will experience 17 kilonewton, approximately 17 point something. And again you can see the strength of this lacing bar in tension is 113. So again it is safe. It can carry tension load, it can carry compression load safely. So therefore we can say that the tensile strength is higher than the force in member. So again it is safe in this criteria also. So that was the solution. Now in the next step we are going to solve for connections that we will do in next part. Thank you.